Hi, great chance. This is part 4 and the last part of this series of probability tutorials. So I am going to try and do an exam-like type of a problem where they've drawn the Venn diagram for you and they are going to ask you some questions based on what you're going to do with the Venn diagram. So reading the Venn diagram with understanding is extremely important here. So let's start by reading the first question. A survey of 100 learners shows that 69 learners have an older sibling, 41 learners have a younger sibling, and 25 learners have both. Again, that means once you see things like both, that means there is going to be a mutually inclusivity here. So there is going to be some intersection that is going to take place there. So we are told that there are 25, so there are 69 learners that have older sibling. Again, remember from the previous session that if you add up all these people in this older circle, they should add up to 69, which is what they have done in this problem. And if you look at this one, there are 41 learners that have a younger sibling. If you add 16 plus 25, you end up with 41 learners. So a sibling is a brother or a sister. That's what they're trying to do here. They're trying to assist those who are in second language English speakers, like me, for example. So this is how they've decided to draw the free body diagram. Sorry, this is not a free body diagram, but this is a Venn diagram. So, but you and me know that this is not enough because I know this must be 100, but I also know that there are some people that should be here. Maybe I shouldn't rush too much, but I could, if I wanted to figure out what are these people. Remember, these are the people that do not have any siblings, whether older or younger. They just do not have any sibling. So we can figure out what those people. But when I look at the first question, that's exactly what they are asking us. They are saying how many of the learners have no siblings whatsoever. But let's think about this. These people here have older brothers or sisters only, and these people here have both the younger and the older, and these people have the younger brothers only. So these ones have one form of a sibling, whether it's younger or older. They do have siblings. So in other words, out of the total learners in this school, then we need to subtract all these people that do have a sibling so that we can figure out those that do not have a sibling. So I'm going to denote it like this. I'm going to say this is a number of no siblings in just simple terms, no sibling, so that we can get it right. So I hope you agree that we need to take out all this sum from the 100 there, which is the sample space. So I'll say 100 minus the sum of 44 plus 25 plus 16 to get the number of the people that do not have any siblings. When you do that, you end up with 15, which means here we must put 15 here. So that's it. That would be a complete Venn diagram in that sense. So, and you would have gotten yourself at least about 2 marks here. So that's it. I hope you understand how we got that. So this is a very, very important skill that you must be able to answer any question. Sometimes they will give you this and then they ask you to determine this. You use the same idea even if they gave you 3 Venn diagrams, but that would be too complicated for you as a grade 10 learner. So let's look at the second question. Determine the probability. We are asked to leave our answer as correct to 2 decimal places. In other words, we will be required to use a calculator. That a learner, okay, so let me reread this. Determine the probability that a learner chosen at random has an older sibling. Okay, if person has an older sibling, I need to be careful. The people here have both old and young, so I must include them. And if you read from the initial statement, they said 69 learners have an older sibling, so that shouldn't be a problem. So we're just going to answer that. The problem, like that, older, let me just say older sibling. Again, I hope you can see that you don't have to write any funny symbols here. So I need the number of older siblings. How many older siblings do we have over the sample space? Okay, over the sample space. So how many older siblings do we have? We have 69. We have 44 plus 25, which is 69 out of 100 learners. I'm into two decimal places, that is obviously 0.69 or 69%. So that's how I would leave it. So that would be the answer for Roman figure 1 here. So we are asked to calculate the probability or determine the probability that somebody will have an older sibling. So again, older this number doesn't mean older sibling, it means older sibling only. So these people do not have a younger sibling. But if we want to consider everybody, then everyone who has an older sibling, whether they have an older sibling only or they have a older sibling and a younger sibling, they belong in the set of the people that have an older sibling. So that's why we use the 69 instead of 44, because 44 does not take care of the other people that are here. So we use 69 for that reason. Now, ladies and gentlemen, let's move on and try to answer the other part of the question, which says, determine the probability that someone or a learner chosen at random has a younger sibling. Again, a younger sibling. This was also mentioned here. 41 learners have a younger sibling. Again, if you want to think about it logically using the Venn diagram, then you would have to add up everybody here, because using 16 only would not be the correct idea, because 16 these are the people that have a younger sibling only. That means if you use 16, you're excluding those that do have a younger sibling but also have an older sibling. So please be careful when you read this problem and make sure that you're thinking about this in the correct manner. So let's write down that probability. So the probability of younger sibling only, or not only, I apologize for that, younger sibling must be the number of learners that have a younger sibling. Okay, how many learners have a younger sibling divided by the sample space. Please always make sure that you divide by the sample space. So the total number of learners that have a younger sibling is 25 plus 16, which is 41 out of 100 learners that were interviewed. Again, in two decimal places, this is 0.41. All right, so I hope you do understand the confusion, the possible confusion there. Please do distinguish between younger only and younger. Younger means everybody, including those that also do have older siblings. Okay, so let's look at Roman figure 3. You are asked again to determine the probability that a learner chosen at random has an older sibling, and this is the key word. It's also written in italics, which means you really need to be careful. And is the symbol intersection. In other words, we need to look at this part here, at the intersection of that Venn diagram. So the probability that someone has an older, let me write it like that, an older and younger sibling must be the number of older and, if you like, younger divided by the sample space, okay, which is going to be given by the number of, here in the intersection we have 25, which is going to be 25 out of 100, which must be 0.25 in two decimal places. That's 0.25. Now, ladies and gentlemen, let's do the last question on this part, with the hope that you are following and you understand how we are making these decisions here. So let's look at this one. They're saying no siblings. Calculate the probability that someone chosen at random has no siblings whatsoever. Well, we just did that at the beginning. We did calculate the number of people that have no siblings here. We did do that. So let's try to calculate that. So the probability here, the probability that someone has no siblings must be given by the number of people that have no siblings divided by the sample space. Okay, sometimes you might find it boring and tiring to be too precise. It's totally up to you, as long as you will be able to show the fractions, the numbers that the marker or the examiner is looking for. But I also find it very important that you should be as detailed as possible as you can, so that you understand what you're doing. So the number of no siblings are 15. So we are going to have 15 out of 100. So in two decimal places, that's going to be 0.5, which is 15%. So I hope you do understand how to go about solving these problems. Again, what I wanted to emphasize here is not making that mistake. Let me just introduce one last question here. Let me introduce one last question. What if they asked us the probability that someone has an older brother, an older sibling, or a younger sibling? What if they asked you that question, younger sibling? How would you solve that one? Well, I hope you remember from the previous session that we said if we are asked or, we would have to add up all these terms. So that's what we would do. We would say the probability of older or younger would be given by 44 plus 25 plus 16 all over 100, which to two decimal places can be calculated as follows. Using your calculator, you can simply say 44 plus 25 plus 16 all over 100, which is going to be 85. Okay, 85%. That's going to be 0, oh my bad, that's going to be 0.85. That's 0.85 here. Okay, excuse me for that mistake. So that's it. That is going to conclude the part 4 of probability, and I hope you do understand what's going on. So for example, again, this question is very tricky and very important. What if they said someone has at least one sibling? Well, that means greater or equals to 1. That means the same question, older or younger. So you would add up all these people, because this person has a sibling, or this person has 2, greater, which means at least 1, etc. here as well here. So please do think about these types of questions carefully. So that's what this means. So that would be the same question. So if they want to trick you, they would put it like that, at least 1 sibling, which means greater or equals to 1 sibling. Okay, so thank you. I hope you understood that and enjoy probability. It is not as scary as some people make it out to be.